So in this video, I'm going to be doing some more practice problems on composite functions and exponential functions and recursion. I guess I totally forgot we went over that in this chapter. It's a quick chapter in this book. So at this point, if you needed some additional problems to try, or you just needed more practice, hopefully this can be a good resource. Okay, as always, I recommend you look at the problem first, pause the video before I provide my solution and share my thought process of how to solve the problems. Okay, number one, if f of x is square root 2x, g of x is 2x squared, what is the value of f of g of 1 minus g of f of 1? So go ahead and try this. So what's g of 1? G of 1 is 2 times 1 squared, which is 2. Okay, what's f of 1? Okay, that is square root of 2 times 1, which is square root of 2. Why do we need those? Well, we need f of g of 1. So what's f of g? We found g of 1 is 2, okay? And then minus g of f of 1, we found that to be square root of 2, okay? So what's f of 2? That is square root of 2 times 2, okay? And g of square root of 2 is 2 times square root of 2 squared. Okay, so this is square root of 4, which is 2. This is 2 times 2, that is 4. So the answer should be negative 2. Okay. F of x is square root of 625 minus x squared. G of x is 225 minus x squared. What is the value of f of 5 minus g of, I think this is a typo, g of 5. So what is f of 5? That is 625 minus 5 squared is 25. So what's square root of 600? Maybe we don't need to simplify yet, so let's leave it like that. G of 5 is square root of 200 if I plug in 5 into there, right? Now, what is f of 5? That's f of square root of 600, which is 625 minus 600, which is square root of 25, which is 5. And g of 5, see, this is why we shouldn't have simplified. I was lazy, so I didn't, but I had a hunch also that the numbers would become nice. So this would be square root of 225 minus 200, which is square root of 25, again, which is 5. So 5 minus 5, that is 0. Population of a certain town doubles every 25 years. If the population of the town was 5,200 in 1980, in what year was the population 6,400? So go ahead and try this one first. Okay. If you see my other video, I don't know the model off the top of my head. I could probably guess and make a good guess or even derive it. Or I can use the basic exponential growth decay model that you need to know eventually for like calculus and all that. But let's say you don't know any of that. I'm just going to brute force start from here and start doubling. Okay? So let's assume we have a calculator for this problem. So it doubles every 25 years. So let's say you start from 6,400, okay? If we double, then we get 12,800. Okay? If we double that, we get 25,600. And if we double that, we get the 51,200. Okay? So this tells us that it was in 1980, it was this number, 51,200. So it doubles every 25 years. So 1980 minus 25. 1955 minus another 25, that's 1930, minus another 25, that is 1905, and that's the answer. So you could totally do it like this. Didn't take that long. Obviously, if you know the model, it could be quicker, but again, that, since I don't remember it off the top of my head, it would take additional time to derive it or make a really good guess. So I'd rather just spend the time to do it like this. It was not too many iterations, as you saw. Okay. Half-life of a radioactive substance is, okay, so that's defining half-life, blah, blah, blah. How much of the original amount of the substance to the nearest whole gram will remain after 140 years? This is multiple choice, by the way, so go ahead and try this. So, how much of the original substance will remain after 140 years? So, it says the half-life. Well, the half-life is 28 years, it looks like, right? Because from the start, it had 1200. Half of 1200 is 600, so the half-life looks like it's 28 years. Okay? So, remain after 140 years. So, is 140 divisible by 28? I believe it is. If I did it in my head correctly, it should be 5, right? So, after 140 years, it halved 5 times. So, what does that mean? So, 1200 times half, it halved 5 times. Because after 28 years, it halves 1. So, to the first power, we just said that after 140 years, it would have 5 times. So, to the 5th power, so this is 1200 over 32. And what is that? That's 37.5. I put it in my calculator to the nearest whole gram, so it should be 38, right? Okay. Radioactive substance decays at a rate of 18% per year if an initial amount was 100 grams, which the following functions model. Okay, so this is the basic exponential growth decay model, but again, if you don't remember the model, let's try to use the tactic I used in the other video. When t is 0, you should have the whole 100 grams because no time has passed. When t is 0, there's 100, t is 0, there's 100, t is 0, that is 0, cross that out. T is 0, this is 0 as well. We crossed 2 out already. Okay? So after 1 year, 18% is gone. So how much of it is left? 82%. So after 1 year, you only want 82% of 100, which is 82. This is easy numbers, so it should be B. Okay? This is saying that you only want 18%. You only want 18% of the original, which is not the case. It decays by 18%, so you lose 18%, which means you still have 82%. So that's B. Okay, so again, I didn't need to use the model or anything, even though this one's pretty easy. You can totally think of it like this, like I did right here. And in the previous videos, I did it like that as well. Okay. The expression above, compound interest, I'm not going to, hopefully you see that. I'm not reading the whole thing. I'm just picking out key information to try to save time. Initial amount, which following expression shows the difference between the value of a 15-year investment, 6% annual compound interest, 12-year investment at 6% annual compound interest. Okay, so let's underline difference. It's asking for difference, okay? This is the general model for the interest, where R is the interest rate, T is the amount of time. So let's just write out the 2 different cases, okay? Between 15-year investment at 6% compound annual interest, 12-year investment at 6% annual compound interest, okay? So for the, let's call it case A and case B. So this one's A, this one is B, okay? For case A, if we use this, it'll be 5,000 times, well, R is 6%, so 0.06. It should be 1.06. Okay, because it's 6 over 100, which is 0.06, as I said. So 1 plus 0.06, that's 1.06 to the, how many years? It says 15 years, right? And case B is the same initial amount. The interest rate is also the same, but then it is 12 years only. Okay, so this shows the difference between the value of a 15-year investment and a 12 years. Okay, so difference, so we're just going to subtract the 2. Okay, So it's 5,000. Well, technically, if it's this minus this, I can factor out the 5,000. So it'll be 1.06 to the 15th power minus 1.06 to the 12th power. Okay? And that looks like it's C, right? Okay? So you just have to be careful here to not simplify any further here. You have to know your algebra really well. You can't simplify this any further. You can't combine it like it's did in choice D. That's totally not valid. Okay, well, if you divided these two, then this property holds, but that's not what we had. And similar here, that's not what we had, right? We're taking the difference. We can't use any property of exponents to get to this, and similar to that. So don't get tricked by the choices, is what I'm trying to say. Okay. Price P in dollars of a truck 2 years after it was purchased is given by this function. To the nearest dollar was the price of the truck 9 years after it was purchased. So that's just T equals 9, is it not? So we're just going to plug in 24,000 times half to the 9 over 6 power. Plug that into your calculator, you should get 8485.28. So to the nearest dollar, 8485. Okay. A and 9 refer to this function, the graph above, population in 25 days, population T equals 0 is 100. This is the exponential model. What is the value of D in the equation? Okay, so let's just pick another point. That's probably nice to use. For example, 20, it's at 400. So we have 0, comma 100, and we have 20, comma 400, okay? So the output is 400. It's 100 times 2 to the T is 20 for this one. 20 divided by D. Okay, so let's start solving for D. So divide by 100 on each side. That's 4 is 2 to the 20 over D, which I can write 4 as 2 squared is 2 to the 20 over D. So match the powers. 2 equals 20 over D. D is 10, clearly. Okay, so we kind of did it like that. Or, if you know that this is the doubling model, how many days did it take for it to double? It's 10. So we kind of use this point as well. Actually, I, for some reason, didn't see that. But yeah, if you know this is to be the doubling model, D is the amount of time it takes to double. So from 100 to double to 200, it took 10 days. So you could totally did it like that as well, or you could do it algebraically like I did here. Okay, what was the population of the insect after 15 years to the nearest whole number? Okay, so we found D. Now they said this is our T now. So we just plug in. It'll be 100 times 2 to the 15 over 10. Okay, plug into your calculator. You should get 282.84, so round up to 83. Okay, and that's it for this chapter review. Pretty simple, hopefully. Okay, there wasn't really any tricks now that I'm looking at it. You just, again, had to know how composite functions work. You got to be careful with that. Models, again, I don't really recommend you memorize. If you want to, by all means, go for it. Otherwise, you can just, like for these two problems, just, it's usually not too bad, right? You can brute force calculate things, or you can plug in special cases, like when T is 0, you have the initial value, you should get back the initial value and all that. Okay, otherwise, anything over here to recap? I don't think so. This is just being able to use the model, knowing what the variables are, and seeing which of the variables the problem gave you and which one it's asking for. So that's simple problem solving skills in general. Okay, hopefully this was of help to you, even if you just got additional practice. That's always good. Please like and subscribe if you found this helpful in any way. And we're going to start the next chapter, which is on, if I can turn the page, polynomials in the next chapter. So in the next video, I'll be starting that. So please look out for that if you're interested.